Welcome back to chemistry class. Today we're talking about different types of chemical reactions. One common type of chemical reaction is called a decomposition reaction. During this type of reaction, a complex compound is typically broken down, usually very slowly, into its more basic components. The one we're going to do today is commonly called elephant toothpaste. Really what it is hydrogen peroxide, which is a basic antiseptic that's found in most households. However, this solution is a little bit more concentrated. It's 30% versus a typical 3% in your bathroom. Okay, so we're going to take this hydrogen peroxide, which is symbolized as H2O2, and we'll use about 50 milliliters of hydrogen peroxide. Then, just to add a little bit of a dramatic effect, we'll add a little bit of liquid soap and some blue food coloring. Most toothpastes are blue. And we'll just make sure that that's good and mixed up. Now during this decomposition reaction, the soap and the food coloring have no effect whatsoever on the reaction. It's just going to be the hydrogen peroxide that's going to be broken down into its more basic components. This process is usually occurring naturally in the hydrogen peroxide, but it's very, very slow, so it's not usually visibly seen. So we're going to speed this reaction up by using what's called a catalyst. A catalyst is just something that has no direct effect in the chemical reaction, but will help speed up the process. The catalyst that we're going to use is potassium iodide. So we're going to add a scoop of potassium iodide into our elephant toothpaste to speed this process up. And as it begins to foam up, the hydrogen peroxide is actually being broken down into water in the form of vapor, as well as oxygen gas. The soap allowed this to be a little bit more visible. Also during this process, heat is given off. This is getting very warm, so it is what's called an exothermic reaction as well. We've labeled it on the board, decomposition reaction. We've got hydrogen peroxide is going to break down into water and into oxygen gas. At this point, this equation is unbalanced, so the law of conservation of mass is not being upheld. So it's now going to be our job to make sure that we balance this equation. Good luck.